Welcome back to the MarkLogic Security Series. In this episode, we're going to explore element level security. To follow along with the hands-on exercises in this episode, make sure you've got MarkLogic 9 downloaded and installed. You can also download the code examples from the MarkLogic University GitHub site, look for the security project, and check out episode 10. In this video, we're going to describe what element level security is, create a protected path, define query role sets, and test element level security. So what exactly is element level security? When you load or update documents in MarkLogic, you manage permission metadata to define what roles can read a document, update and delete a document, insert new nodes into a document, or in the case of code, what roles can execute a specific module. Document level security is powerful, and for some use cases it's all that you need, but sometimes it's necessary to implement a security model that is a bit more granular than the document level alone. Element level security is available in MarkLogic 9 to provide control at the XML element or JSON property level. This means that specific information inside a document may be hidden from a particular user based on that user's roles, while still providing access to other information in the document if appropriate. So let's revisit the memo document that we worked with earlier in the tutorial on redaction. Remember that when we performed a search as the bond user, we were able to search across the entire document. Now, we redacted certain parts of the document when we displayed it, but we were still able to search across the whole document, making it potentially possible for a user to discover data that we might wish to protect. Now let's implement element level security so we can have a proper, strict model that would eliminate the possibility of this information to leak. And in our example, will fully conceal the contents of the name and location properties from a user like Bond. So remember that this is based on the tutorial that we completed on redaction. And in that tutorial, we set up some users and roles. Our goal is to implement a model that will allow users with the secret read role to read the contents of a memo except for the source name and source location property. This means that if our bond user searched for Barcelona, that this document should be in the results set. But we want to require a user to have the top secret read role in order to read the properties indicating the name and location of the intelligence source. This means that if Bond were to search for the word Silva in our memo document, he should not be able to see that document in the results set. But if M were to perform that same search, that document should be a part of her results set based on the role definition. To implement element level security, we need to complete several steps, including setting up our roles and users, creating protected paths, defining role sets, and testing. So let's start with our basic setup. To get started, we'll import the workspace, which you can download from the MarkLogic University GitHub site. So through Query Console, I'm going to choose Import Workspace, and then I'm going to navigate out to wherever I've stored that on my file system. And I have placed all that content from the GitHub site in a folder called MLU On Demand. And if I drill through here, I'm going to find the Element Level Security workspace. So let's go ahead and bring that in. And if you have been following along and you've completed the redaction tutorial, then you're already set up. But if you have not, these first three tabs will help you get that setup complete. You can run the Setup Roles tab, which uses server-side JavaScript to build a request to the Management REST API to create the necessary roles for our project. You can then run the Setup Users tab, which uses JavaScript and the Management REST API to create the Bond, M, and project default users. And then you can run the script called load memo doc, which will create that memo JSON document that we discussed. And if you look at the code that inserts this document into the database, you'll see that we are defining document level permissions. giving the secret read role and top secret read role read permissions on that document. Now that we've set up the users and roles and created the sample document that we need for our project, the next step is to create a protected path. You can define permissions on an element or property by defining a protected path. This is done by specifying a path expression and permissions. For example, you could define a path that selects any name property and give the top secret read role a read permission on that property. This would automatically exclude any users who do not have the top secret read role from being able to read the name property. Or you could be a little more selective with your path expression. In the second example, you would only be selecting name properties that are children of source properties. Or in the third example, you are selecting source properties where the word agent is present in the source property itself or any of its children. To set up a protected path, you can use the admin interface. And here we see a screenshot of how a protected path is defined using the admin interface. Note that you define the path, and for XML elements you can define any namespace bindings that the path expression requires. And then finally you define the roles and capabilities that will be granted. You could also create a protected path programmatically, and that's how we'll do it in our hands-on exercise. Regardless of how you create the protected path, you should be aware that it does require a reindex when you insert, delete, or update a protected path. If you need to add multiple paths, you might wish to disable reindexing on your database configuration, add all your protected paths, and then turn reindexing back on. So let's go ahead and create our first protected path. Let's take a look at the tab titled Check Protected Paths. When we create a protected path, the configuration details will be inserted as a document into the security database. This document will be in a collection. So let's run a simple query to see if we have any protected paths defined in our security database. So if we go ahead and click Run here, we'll see that we get back an empty sequence. As you can see, we currently do not have any protected paths defined. So let's create one. Let's take a look at this tab titled Create Protected Path. Remember that protected paths may be created using the admin interface or programmatically. Here, we are going to create one using JavaScript functions. And because this is a security configuration, we need to run this code against the security database. To create the protected path, our code needs to define three things: the path which defines the element or property that we wish to protect. In here we are defining an XPath expression that will protect name properties that are children of source properties. The second thing that we need to define is any namespace references. Path expressions for XML documents may have namespaces defined. JSON properties do not have namespaces defined, which is why we are setting that parameter to null. And finally, we define the permissions and then call the function to create the protected path. So let's go ahead and run this code to create the protected path. And now if we go back and run the prior tab titled Check Protected Paths, we should see that we now get our new path returned. And we can see it returned, modeled as a document coming out of the security database. Now that we've created our protected path, let's go ahead and test it out. Let's take a look at the tab titled Test Read. In here we are using the fndoc function to read the document from the database as the bond user. And we can see that when we run this, in the document that gets returned, that the name property is not part of the returned data. And this is because our protected path states that a user must have the top secret read role in order to read the data in the source/name property. And Bond does not have that role. Now let's see what happens if we read the same document as the M user. And remember, our M user does have the top secret read role. So I'm going to go ahead and change this to M, and now when we run this code, we can see that the source name property is returned as designed. But what about searches? Next, let's take a look at the tab titled Test Search. Remember that in our redaction tutorial, we saw the potential for information leaks. And I mentioned that the primary use case for redaction was on export, but that it's possible to use redaction on read. And if you do so, in order to properly secure things, you should combine it with element level security. So now let's see what happens when we try to do that same search from earlier, looking for data that we know is in the name property. And we're going to try to run this search as the bond user. And when we run this code, you can see here that we get no results. Now let's try to search for a term that is not in the protected path in that memo document. So instead of looking for the word Silva here, let's go ahead and look for the term Barcelona. Now when we run this code, we see that we do get the document back because we're searching on a term that is readable by the bond user based on the document level read permission given to the secret read role. Now we also see again that the name data is not given to the bond user, again the enforcement of our property path. Now let's try searching for a term in our protected path as the M user. So I'm going to go ahead and change our user here to M, and I'm going to go back to the original search, which was looking for the term Silva. Now let's go ahead and run this. Now that's interesting. Our M user also gets no results back. But she has the top secret read role, so I would have expected her to get the document back. In order for searches to give us our desired results as implemented in our element level security model, we need to understand and define query role sets. So let's discuss query role sets. A query role set is a set of roles. Queries that we run will reference the role sets based on a user's role in order to apply the element level security defined in our protected paths. Creating a query role set is simple and can be done either programmatically or via the admin interface. Now we know from our testing in the example that we need to define a query role set because the results that we got when we searched as the M user weren't exactly what we intended in our security model design. But let's dig a little deeper into why we need to define query role sets. When you insert or update a document in your MarkLogic database, the document is parsed and the terms are added into the universal index. So let's visualize what that means by imagining a really simple document. And let's say we inserted this doc into our database with a read permission granted to a role called secret read. We can visualize what the index for this document would look like. Note that in reality, hashing is used inside of these term list indexes, but for visualization purposes, let's imagine it looks like what we see here. Now, with document level permissions in place, if a user searches for documents that contain the word hello, we determine based on the user's roles which documents they can read, and MarkLogic would return the appropriate documents. But with element level security, the index is structured a bit differently. Let's imagine we set up a protected path on P1 properties that occur anywhere in our documents. That path definition would look like what we see here. Now we know that when we create a protected path, that it will require a reindex of our database. So what would this new index look like? You can visualize it like this. For terms that occur in a protected path, the index now contains each term combined with the roles and capabilities defined in that protected path. This is important in guaranteeing that no leaks of protected information will occur when a user performs searches or unfiltered queries, because during searches, the query terms and the user roles are combined to find appropriate information in the indexes for that user. Now, in more complex security models, it's possible to have many roles and users that have many different combinations of roles. And this is why we need to define query role sets. MarkLogic is built for speed and scalability. And by using role sets, MarkLogic reduces the need for query expansion by telling the parser which term and role combinations to try, therefore resulting in both high security and great performance. So let's define a query role set and test out our searches again. Let's start by taking a look at the tab titled Necessary Role Sets 1. Now our security model in this example is simple, but in a more complex model, you might have many protected paths and therefore need many role sets. MarkLogic provides functions that make it easy for you to determine which role sets you need, and then we provide functions that can create those role sets for you. The XDMP database node query role sets function is useful if you've already got a certain document type in your database and you want to know the role sets you need in order to search that type of entity based on the protected paths you have defined. The first parameter in this function is the document that you wish to check, and the second parameter can be either unconfigured or all. All would bring back all the necessary role sets, even if they are already configured in your environment. Unconfigured will tell you what role sets are needed but not currently configured. Use this option when you've added some new protected paths to an existing element level security implementation and you only need to know what new role sets you need to create. So let's see what this would return for our memo document. So let's go ahead and run this code, and we see that the result in the response data says that to search this memo document, we will need one role set. And that role set refers to one role by its role ID. Now if we wanted, we could see which role this ID represents. So I'm going to copy the role ID here from my response data, and then I'm going to take a look at the tab titled Role Name. And I'm going to go ahead and paste that role ID here into the function call for security get role names. Now this needs to be ran up against the security database, and when we run this, we can see that this role ID represents our top secret read role, and that's what we would expect based on our security design. Now let's take a look at the tab titled Necessary Role Sets 2. Another way to programmatically determine what role sets you need is to use the XDMP node query role sets function. Here you just build a document in memory and it will figure out what role sets are needed in order to search this type of document. Now this is useful if you don't have a specific document already in your database that you wish to use, or if your security model doesn't permit you to have read permissions on that type of document in your database. So let's go ahead and run this to see what we get as our result. And here we get the same response because the document that we built in memory also has a source/name property just like our memo document. Now just for fun, let's make a simple change and see what we would get. Instead of a document with a name property, let's make this a fname property. And now when we run this code, we don't get anything back because we don't have any protected paths matching this type of document. And therefore, no role sets would be required in order to search documents that look like this one. Next, let's take a look at the tab titled Create Role Sets. Now that we've seen the functions that can help us determine which role sets we need, let's combine that with another helpful function that actually will create them. We'll use the XDMP database node query role sets function to bring back the definition of the role sets we need. And we'll pass that information to the security add query role sets function, and it will create all those role sets for us. Note that because we are determining what role sets are needed based on a document that lives in our documents database, we're going to eval that particular query against the documents database. But the role sets themselves will live in the security database, so that function call must go up against the security database. Let's run this code to create our role sets. Now that we've created our role sets, let's go back and test our searches. And the first thing I want to do is I want to test as the bond user. So I'm going to run this query as bond, looking for the word Silva. And I can see here that I get no results as bond, and that's to be expected. Now let's run this query as the M user. And remember, before, M did not get any results because we did not have the query role sets. Now when we run this, we get the results that we initially expected. M is able to read this data and get the results back. Next, let's take a look at the tab titled Exercise. Now that we've successfully implemented an example of element level security, it's your turn to try it on your own. Your mission is to implement element level security to ensure that only users with the top secret read role can read the contents of the location property. Go ahead and pause the video here and try it on your own using this Exercise tab. Now if you get stuck, you can take a look ahead and reference the solution that is outlined in the tab titled Answer. In this tutorial, we introduced the key concepts around element level security. To learn more, make sure to read the Understanding and Using Security Guide in the documentation. In this episode, you learned how to describe element level security, create a protected path, define query role sets, and test element level security. Make sure you get MarkLogic 9 and that you get the examples so that you can follow along with these exercises at home and have a reference point for your own machine. And if you need additional training, make sure to visit marklogic.com/training to learn about all of our various training options.